So we've already talked about how to use substitution, which is using algebra to solve one of these systems. And remember, when you're solving the system, you're finding the values of two variables that work in both equations. This second method is called elimination. And it's all based on the fact that if I have two equations, okay? Now, if I solve this, say, by substitution, or say I solve it by graphing, it will work out that this is 2 and this is 1. Because 2 times 2 plus 1 is 5. 1 plus 2 times 1, sorry, 2 plus 1 times 2 is 4. It works. Okay, it's a solution. If I were to add these two equations, meaning add the x's, add the y's, add the numbers, notice we do it almost like vertical addition that you guys learned way back in junior school. I get a new equation. If I add the x's, I get 3x. If I add the y's, I get 3y. And if I add the numbers, I get 9. Guess what? The solution that worked in these two will work in this one too. Makes sense. 3 times 2. Three times 2, which is 6, plus 3 times 1, which is 3, does equal 9. I can subtract the equations too. And the equation I get after I subtract will have these as solutions as well. So if I took 2x plus 5y equals 5, pardon me, minus, and I'm going to put it in the second one in parentheses, just to remind myself that I'm subtracting everything. So what's 2x minus x? 2x minus x. 1x. What's y subtract 2y? Negative 1y, which is negative y. Is that what you said? Okay. And then that equals 5 minus 4, which is 1. Notice the solutions that we already figured out, 2 minus 1 equals 1. It works. What that means is we can actually, when we get a system of two equations, we can add or subtract them to eliminate one of the variables, solve for the other. And as soon as you got one, you plug it back in to find the other. Now that, I know that'll make more sense when we actually do an example. So let's say this. Let's say we're asked to solve this system. So I'm going to rewrite it. And I'm going to line them up so that the x's line up. The y's line up, the equal signs line up, and the numbers line up. And I'm going to call this equation 1, and I'm going to call this equation 2. Much like we did with substitution. Could you add or subtract those equations to eliminate one of the variables? If I add them, will one of the variables cancel out? 2x plus x, y plus y, nothing cancels out, right? So adding doesn't help me. But if I subtract equation 1 by equation 2, so I'm just going to rewrite it. So 2x plus y equals negative 7 minus x plus y equals negative 4. Two x minus x, y minus y. What do we think? Nothing. They cancel. So the y's gone. Equals. Be careful with this because there's two negatives. -7 subtract -4. -3. Notice we eliminated the y's, and actually we got an equation that tells us what x is. So we're halfway done. So we know that x is -3. So all we have to do is plug -3 back into here or here to figure out what y is. Which one would you like to sub it back into? So sub x equals -3 into maybe the second one. Looks a little easier. And then solve for y. So when we do that, well, instead of x, I write -3 plus y equals -4. And that's a pretty straightforward equation to solve. What's y? -1. So we got our two answers that will work in both equations. And remember, you can either write it like this, x equals -3, y equals -1, or you can write it like a coordinate. Either one, you don't have to write both. I like elimination. It's a good one. Yeah.
So it doesn't matter, like, when you're subbing numbers in, it doesn't matter which equation you sub in?
No, not for elimination. Doesn't matter. Yeah. Okay. Now this one, right away, I'm going to go like this. Now, if you look at it, if I add them, no variable will cancel. If I subtract them, no variable will cancel. Right? Because if I add them, I'm going to get 8x and then 2y, or sorry, -10y. If I subtract them, I'm going to get -2x and 2y. So here's what I can do is I can multiply. Remember, like when we get rid of fractions in equations, as the equation stays the same as long as we multiply everything by the same. So I want to make these two the same number. I want to make the x's the same number. What would I multiply this? What would I have to multiply each by so that they would be the same number? The first one by and the second one by? First one by 5, second one by 3. Perfect. So I'm going to take equation 1 and times 5. I'm going to take equation 2 and multiply it by 3, and that's going to make two 15x's. So to cancel them, what do? Subtract. So when I multiply equation 1 by 5, everything gets multiplied by 5, so 15x minus 20y equals 7 times 5, which is 35. If I multiply the second one, everything in the second one by 3, I get 15x minus 6y times 3, which is minus 18y, minus 8 times 3, which is 24. Now I can subtract those equations because it's going to get rid of x and allow me to solve for y. Now be careful with your negatives. Remember, it's -20 subtract -18. So it's actually -20y plus 18y, which is -2y. Here, it's just 35 minus 24, which is 11. What's y? Solve for y. -11 over 2, correct. So we're halfway there. Now we take that answer for y. And we plug it back into one of the two originals to figure out what x is. Doesn't really matter which one in this case. So let's just say in one, and we're going to solve for x. So if I do that, I'm going to get 3x I'm going to get 3x minus 4 times y, which is now like negative 11 over 2, equals 7. Unfortunately, this is not, when we multiply this, it's going to work out to an integer. It's not going to be a fraction. Remember, what's negative 4 over 1 times 11 times negative 11 over 2? 44 over 2, which is 44 divided 2, 22. Looks like I'm not going to get a fraction for this second one, which is good. Okay. Next, subtract 22 from both sides, and I will get 3x equals negative 15 after I do that. Last step, divide by 3, x equals negative 5.
Fraction, so they 11 over 2 went to like not divide it, like the brackets are.
Sure. Like here?
Yeah. Like, you know what, sometimes you do, like, you have to multiply everything by 2?
Yeah, to get rid of the, yes. Well, this isn't, I only do that if there was, say, an x in here,
Oh.
right? So like if this was negative 4 times x over 2, that's when I go like this.
Okay, otherwise we just do that.
Yeah, otherwise you just multiply the numbers.
Okay.
Yeah, good question. So therefore, final answer, x is negative 5, y equals negative 11 over 2, or negative 5 comma negative 11 over 2. Now we're actually going to skip a couple questions in this. We're not going to do the next example and the last example. We're just going to do the word problem. But I just want to, just so we understand, you don't have to write these down, but let's say I gave you this system. What would you do to eliminate one of the variables? Remember, you can multiply one or both of them. Don't have to be by the same numbers. And then you can add or subtract to kill one of the variables. I always look at the x's. How can I make the x's the same? Multiply this one by 5 and then subtract. It'll take them out. This one. Again, focus on the x's.
How'd you make them the same number so that I could subtract them and kill the x's?
Times this one by, times this one by. Times this by 4 to make it 28. Times this by 7 to make it 28.
Yeah.
Come on.
Yeah, all I have to do is multiply this one by 3 to make a 6x, and then I can subtract them to take out the x. Okay, that's how we do it, using elimination. Sometimes it may be set up that you can add or subtract and take out one of the variables right away.
A lot of times you may have to multiply just one of the equations by something to make the x's the same as the other. Sometimes you may have to multiply both of them by different numbers to make them the same x's. Okay? All right, let's look at this one. Remember, these always have two unknowns. So Ms. Welks decided to purchase M&M bags and Hershey bars for all of her students. Each M&M bag costs $3, each Hershey bar costs $2. She purchased 16 of them, and the total cost was $41. Out of all of that, I gotta make a system. And once I make the system, I gotta solve it. What are my two unknowns? M&Ms and Hershey. What variables would you like to call them? It's up to you.
Sure. You can call them by your initials if you want.
Okay, so there's our two variables. Now we got to make our two equations. She purchased 16 of them. How would you turn that into equation? Yeah. If I add the M&Ms and the Hershey bars, the number of them, I get 16. So that's the number of them. Now it's the value one. How much is a M&M bag worth? And Hershey? And if I combine those, I get 41. So that means each M&M bag costs 3, plus each Hershey bar, which costs 2, will get me the total cost that she spent, which is 41. Okay. So we got that. We're done with A. Now we can solve B. And I asked you to use an elimination.
Because I want you to practice, like we did one with a problem with substitution before. We did one with elimination before, but after this exercise, you will have the option of choosing which one you want to do. I'm just going to say solve this problem. You decide how you want to solve it.
But for this one, we're going to use elimination. So let's, like I said, focus on the first ones. What can I do to make the variables the same so that I can subtract them? Times the first one by 3. So number 1 gets multiplied by 3, and then I'm going to subtract equation 2. That's going to take out the m's and leave me the h's. So that's going to leave me 3m plus 3h equals 48. 48. The next, the second equation did not change at all.
What does it look like when I subtract? 3h minus 2h. H equals 48 minus 41. 7. So we got the number of Hershey bars, 7.
Well, this seems to be the easiest one to put it back into. So let's sub h equals 7 into 1, which allows us to solve for the number of M&M bags. So that's going to give us M plus, well, we already know h is 7, so we can replace it, equals 16, which means M is
9. And then, of course, with the problem situation, we want to write our final answer in a brief sentence. And you can just simply say, there are 9 M&M bags and 7 Hershey bars. And that would be our final answer. Okay.
Are you gonna say which one we have to do? That's
For the problems on the test, no. Yep. The only ones, what it's going to look like on the test is the only ones would be, they would look like this. I would give you this with X and Y, and I would say solve by elimination. Or I would say solve by substitution. Okay, but for a word problem, I'm just going to say solve, which means you get to choose. But I do want you to be able to show me you can do both methods. In addition, of course, to the graph. Well, we graph each side, graph each equation. For where they intersect, ringing a bell there. Yeah, just now. Okay.